Hi everyone, how are you? Well, really excited to be here. Today I'm with Elian. We're going to introduce ourselves, but we are going to talk about going offline first with Flutter, best practices. So first I wanted to know, maybe in the crowd, how many of you guys have implemented an app with this approach, offline first? Maybe you can raise your hand, just to, okay. And how many of you guys have encountered any problems on making an offline first approach? Maybe you can also, okay. So yeah, it's a really difficult topic in my opinion, mainly because there isn't so much information out there. So yeah, hopefully in this meeting you will grasp a lot of approaches and techniques that will help you, demystify this topic, right? So a little bit about me, in case you don't know me. I'm Gianfranco and I'm CTO and co-founder of Somnia Software. Somnia Software is a dev shop specialized in Flutter. We are we provide services to clients around the globe. And yeah, we've been around for more than 5 years, from the very beginning of working with Flutter. I'm also a Google developer expert for Dart and Flutter. I'm a software engineer. I have a computer science degree. And also I consider myself a Flutter developer and a mentor. And I'm also a speaker. I really like to speak in conferences. And also I'm from Uruguay, so there in Montevideo, I'm organizer of Flutter Montevideo meetup, where I currently live. So maybe Elian, if you would like to introduce also.
Sure. Hello, everyone. My name is Elian. I'm a technical leader at Somnia Software. I also have a background in software engineering and computer science. I am a speaker. I've stuck in many meetups and in Flutterconf LATAM community. I'm a content creator. Sadly, you are not probably going to recognize me because I mainly publish content in Spanish. So there is a big community of Flutter developers in Latin America, and there were basically no content in Spanish. So we decided with a friend to start publishing content there. And I have a small community called NoScope Devs. So it's a YouTube channel and a Discord server with a couple hundred developers. And we just try to share our experience. It's good that it hasn't grown that much, so that it's very consistent and we get a lot of feedback in there.
All right, thanks, Eli. So yeah, this is the agenda for today. As I was saying, we're going to talk about offline first. The first things we're going to talk about is why offline first matters. Then we're going to make a little bit of a change of mindset in the way of working now and think later. We're going to present some things called optimistic UI updates. Also, at some point, you will have to deal with conflict resolution. We're going to see a few strategies there. And we are going to also present some packages and tooling, so we don't have to implement everything from scratch. And lastly, we're going to make some conclusions and next steps, so hopefully you can continue your journey and start building something. So yeah, with that in mind, the first thing I want to talk about is why offline first matters, right? I feel like there are a lot of apps that we use on our daily basis, really popular ones or really small ones, but they reach a point where we, as users, we don't have internet either because, we are on an airplane or something, and suddenly we realize that we have this UI, right? And it's really frustrating because we can't do anything, and suddenly we have our phones that are something that we use constantly, and it's like, what can I do with my phone right now, right? The idea of the talk is that you postpone this UI as much as possible so your user can continue using your apps, right? So we don't have to, for example, present things like this. This is also related because usually we have to put a spinner whenever we have to go back and forth from an API, for example. And this is something really frustrating because we don't know how much time are we going to spend seeing this. There isn't so much feedback as well. So what are the main how this is happening? Because there are some network challenges on the way when we develop apps, right? There are situations where we experience flaggy Wi-Fi, or there are temporary dropouts, or even we are in a context where we are in rural areas, or airplanes, or hospital elevators, like situations where internet is not so good. And I guess that maybe you think that we are not in these situations as much as we think, but I think that there are, for example, for me to come here, I'm from Uruguay, so I have to take an airplane, and it was like 10 hours, so I have no internet for 10 hours, and these situations happens like more than we think about. So what would be like the screen loading time 101, right? Whenever we are working with, let's say, like a traditional way, right? Well, what we can see in terms of performance is that the network is taking the larger time in our flow, right? So basically, if we can reduce the network latency, basically we are going to be more efficient, and suddenly our users are going to experience like a higher performance, because we don't have to wait for a response from the internet, right? So basically, we are going to rely in local storage in this offline first approach, instead of in every interaction with the user and our apps, try to hit the server for our response, right? So this requires like a change of mindset, as I was saying, because we are going to work now. So we are going to execute all of our tasks now, and then at some point we're going to have to sync with the server, so we have the last data and we are not like inconsistent, right? So how will we do that, right? Here, what I want to show is a small video that we record just to kind of like put ourselves in the problem. This is like notes in MacBook. On one hand, we have like a MacBook, and on the other side, we have like an iPhone. And here we are online. So basically, when we are online, everything is flawless because we are connected. And yeah, you can see that we are writing in our MacBook, and we are seeing the results in the iPhone almost in real time, right? But if we turn off the internet in our phone, suddenly we're offline, right? And this is like, could be any situation. And let's say we are starting changing something in our notes in our mobile phone that is disconnected. Let's say we write, this is a note from my tablet, and then we realize we are on our phone, so then we should change this for my phone, right? But this is done on purpose. Whenever we get back connected, we have again connectivity in our phone. How we are going to see this in our MacBook, right? So if you notice, the MacBook Notes app is going to, in a few moments, it's going to reproduce exactly the same that we did in our phone. But it's not going to only say, I don't know if you notice, this is a note from my phone. Actually, there was a moment that it was writing this note from my tablet, so it's kind of like reproducing all of the steps required to be at the last step. And this is something that we are also going to talk about because it's a well-known strategy for achieving this synchronization and this merge conflicts. So this is the demo that we gather. So maybe if we go back, oh sorry. Here. So basically, whenever we are working locally, you have to trust what's on the device. The reliable data source will be stored locally, so we don't have to care about what's on the server anymore. And this requires that you set up a database as the single source of truth in your local device. So this is another challenge as well. So that's why it's not trivial. But you won't be able, or maybe you won't have like the network dependency, and that will ultimately, we will ultimately have like a smoother experience regardless of whether or not you have like connectivity, right? So this is like the bottom line of this topic. So when we are working and now and sync later. This is like a small architectural diagram, so we can all understand like the basic flow. Here we are like in a offline mode, right? And we typically we divide our apps in layers, and in the first layer we have like our view. The view is going to call a block, for example, but you could use like any preferred state management. We are using block here, so and whenever the block has to process an event or something, it will typically call a repository, and here we are in another layer. And the purpose of dividing in layers is that the block will not know where it's retrieving the information, and we can either retrieve it from a local database in this case or from the API. But here, as we are working with abstractions, the repository could actually call a local data source, and the local data source will eventually call a SQLite database, or it could be also another database of your choice. Let's say we're using a non-relational. But what we see the most benefits is in streaming back this information as an entity, and the repository will stream back as a model, as something that we already understand as a dark class. And suddenly we have in our view with a builder, we have like the information in real time, let's say, because whenever we are hitting the database locally, we reactively are showing the responses. And this is happening too fast because we are working now. We are not waiting for the server to, any responses, right? But at some moment, we will need to sync later that information because we have to consider that there are other clients that are that want this information. So at this point, what we can do is the repository will call a remote data source, and the remote data source that is kind of like following the same API, the same contract, the same interface, will, yes, in this case, call the API. So then the API will have the response, and the response we will sync back to our SQLite database. So we are again sync back, and we have the latest information from the server. So this is like more or less like the recommended flow. We're going to expand on this later, but just so you can see all of the layers and involved in this flow and how it's different from a more traditional approach where we rely only on an API, right? Okay, so one of the things that we can do, one of the cool things that we can do on this approach is optimistic UI updates. And here we also brought another demo of one of our apps. Let's say we are like working with switches, and these switches we don't really know. For example, if we touch one of them, we should wait from the response from the server. There are race conditions. Let's say we kind of like need to wait, because if not, we are going to have an inconsistent state in the API. And suddenly something that looks really simple, we start including loading indicators, and we don't know if we should include it in all of the switches or not, and so on. So what we can do is like have an optimistic UI update where we assume that everything is going to be okay. And then whenever the sync is a process, we can either a success or failure. But in that moment, the user is going to kind of like have better experience, because he's not going to see everything about this. He's going to see that it actually worked, right? So what could we do about say about optimistic UI updates, right? We have like an instant feedback. So this is really great because the changes are applied immediately in the UI. We have like a fast response experience even before the server confirmation. So we are assuming that everything is going to be okay. And in most cases, it will be, right? Then we have like the local first approach, because the updates are made locally and syncing the server in the background. So that requires another challenges approach, but it's nothing that we can done. And then the seamless interaction that reduces the need for loading indicators, because everything is going to work flawlessly. So yeah, at this point we can like say everything is fine, and yeah, it's going to work, right? So So yeah, the challenges that start presenting at this point is that the business logic on the client, it starts growing because now we are working with a local database. So that means that every CRUD operation will also happen in the local device instead of only in the server. So we are going to start managing two IDs because entities are going to be created, for example, being offline, so we don't know the ID yet. So we have to manage both in local and server the different IDs. And also we have to maintain relationships between the database from the server and the client. Lastly, also we can say that we have to have more client-side data validation, although this is our best practice, even though we are not like actually using offline first, right? So yeah, we have to enforce data integrity by handling validation rules in the client as well. So, okay, so now we are going to talk about some other topics. So maybe Elian, you can continue. Great.
Sure. So now that we have set the basis with the previous diagram on which we're going to expand later on, now we know that we at least have some sort of knowledge on synchronization. It is going to happen. We have optimistic UI updates because as we are streaming everything all the way from the SQLite database in our case, we found to be the most common one in our projects. As we are streaming the data, we get optimistic UI updates. But then one big question that you get is, how are we going to load all this data at the beginning? So a big concept that it's going to be very important for all offline first apps is delta updates. So bear with me with some diagram and some animations. So let's say we have a device, a mobile device, and our server. And our server is initialized and has already two values, Apple and Orange. It's just a list of words. Then whenever a device first connects, let's say you change phone, you were using an app previously, and it's the first time you install the app and you just run it, the first thing you have to do is just like request a full sync. So that is going to be at T0. So you request the full sync and you ask the server, hey server, send me everything and like get all since 0. So in that case, the server is going to return all the data and you get Apple and Orange now on the device. Everything's happy. But then a big concept gets into the flow, which is timestamps. So of course you need to start keeping track of timestamps because as you are doing delta updates, we need to say, okay, I have all the data up until this moment. In this case, it's T1. So we proceed to save that last timestamp locally. And then at some point in time, you modify, you created something new and some other place from another device, or another device created a new object. And then let's say grape what's added to the list in the server. And based on the conditions on your business logic, you are going at some point in time to request an incremental sync. So that incremental sync is going to do the exact same thing again using the timestamp. So we get all since 1, which was the last update. Then the server returns all the data and you get the last updated timestamp. And finally, you get grape on your app. So there are some things that we have to keep in mind when working with delta updates. So especially initial sync load. Of course, as we are requesting, in this case, everything on this first call, there might be like a couple seconds sorts of data, depending on how much data you're requesting. But that's why we also highly recommend combining pagination and delta updates. So the idea is that based on the business needs, you just request a subset of the data that the user is going to need at first, and then you incrementally, using delta update, you just request what you need based on the conditions. Of course, we need to keep track of timestamps, and just this technique is going to help us a lot when handling large data sets. And then we get into one of the biggest issues of offline first approach, which is synchronization. So previously we saw this general architecture diagram. So again, a big concept is the streaming all the way from SQLite, because we do optimistic UI updates. We try to say that the repository, we try to trust the SQLite and that the operations are going to be completed at some point in time. Now, in our experience, we're going to say bottom left corner, now that we are online. So we're going to add a new component to all this general architecture, which is going to be a sync block. So this is one of the scenarios that we find that we've implemented a lot. So we have a sync block. So this usually, most common scenario is this sync block it's connected to a stream of connection and checking if there's Wi-Fi, if there's no Wi-Fi. And whenever we come back online, the sync block is going to be in charge of handling the whole synchronization logic, which is going to do the exact same thing, go to the API, go back to the repository, and then saving it back to SQLite. So this was one of the most common scenarios that we had, but there were some others where we needed to change it a little bit. So we have the view and the sync block. And then we have a big square in the middle, which is the sync manager. So we were faced with the challenge of creating a new entity that was going to be in charge of handling all the logic behind the synchronization. So you can see that there is a red line between the sync block and the sync manager, because we ended up discovering that the reason right after the sync block, in this case, say, okay, I want to synchronize, there was no need for the block, in this case, or any state management of your choice, needed to wait for it. So we ended up designing, this could perfectly be a fire and forget. So I just said, hey, now I need to synchronize because I have connection, or because any other condition, because the user just did something, or we have cases that just because of the business, we say, okay, every day at midnight, stuff like that. So then the first thing that is going to happen when synchronization starts is going to be that the sync manager is going to go to our SQLite database and say, okay, I need to select everything from this table called sync operations. We're going to expand a little bit into it later, where the status is pending. So all the operations that the user have done that haven't been completed yet. So we get all those operations back in the sync manager, and we start attempting to execute the request that were pending in this case. So of course, now the sync manager is going to attempt to make the request, and we get our happy path. We handle the success case. In this case, it's usually, okay, let's update the status from that operation to done. And then as we just update that in the SQL database, but we already set up our optimistic UI updates, we don't have to do anything for it to reach the UI. Because as there is a stream between, in this case, our feature block, all the way to the SQL database, we just don't need to do anything. The updates just get in there thanks to listenables and observables, in this case, streams. But then we have the other scenario. What if something fails? So in this case, whenever it depends on the conditions, but you can say, okay, the sync manager, if that operation that we requested failed, just put it back into the queue and mark it as retry. So that means that the next time syncing is triggered, we're just going to get it from the list, and we've found cases where they need to be ordered in a particular way, or where the order or the timestamp doesn't matter. But then there's another interesting scenario, which is complete failure. There are some app cases, especially when you're working on a project that only one user is going to be touching the data. You can perfectly say, okay, I'll queue it forever. There's no need for me to say, okay, user, something went wrong. Now I need to do something. So, but there were some other where we actually say, okay, a golden rule is like 3 attempts. So once we try to sync something 3 times and it fails, now we just like revert the change and tell the user, hey, something went wrong. We're sorry. Please try again later. Then I'm just going to go back a little bit. So the red line also helps us a lot, because in theory, in the way we try to set up our projects, all the way from the sync block down to the SQLite or API, it's Dart only. So there's no need of Flutter. So that is important, because that is going to just like make our life a little bit easier when trying to execute Dart in the background. In this case, there was a very great talk just earlier today about Flutter background progress execution. So sadly, I cannot tell you like, oh, I wish you had been there. So hopefully whenever the videos get uploaded, you're going to be able to see it, because just talking about background processing is just like a completely different topic, but in our cases, we've been very happy with the work manager implementations. Of course, it's going to depend on the use case, and there are a lot of limitations. But yeah, I'll definitely encourage you to watch the talk from Dominic when it's published. There are a lot of important hiccups when talking about background processing. But then we get to the point and we ask, okay, now we kind of understand what we need to consider to handle all the syncing logic. How are we going to do optimistic UI updates, delta updates, but where are we actually syncing? So in this case, we found ourselves implementing very constantly the same class. For the projects we've recently worked, we usually use HTTP clients just because of the constraints of the project. And we were very happy with this simple model, which is the representation of the sync operation entity that we just requested from the SQLite database. So we usually have the ID to track the operation and locally and to say, okay, this is sync, this is not sync. And then we get this sync status, which is usually an enum with properties like just created, pending, syncing, or pending retry. So something very funny, well, at least I found it very funny, is that I wanted to use the word new for new instead of just created, but new is a reserved language word, so you're not going to be able to do it. Then you have, of course, you need to keep track of the timestamps and a remote operation type. Again, as in our case, the most common scenario was working with HTTP clients. We decided to put this in here so that whenever we reconstruct the operation, it's very easy to do. We have the request path, so where are we making the request, and the data that is going to be in that request. So yeah, that is the model that we usually use. Then we get into another complex topic about conflict resolution. So bear with me for some dashes from here. So let's imagine we have a server which at T0 has this dash star, very simple. And then we're going to introduce device A, which is going to receive a copy of this when it connects. Same thing, device B receives a copy of this. So then at some point in time, device A decides to add a scarf to dash, but then this device B decides to add a hat. Device A sends the update to the server, so it gets first there. And then we have device B trying to update the same record in the database. So there is going to be a conflict. There's going to be an issue, and we don't know what to do there. And if you are not careful, so this happens when multiple devices are updating the same data. And the question starts, what can we do in these scenarios? So there are two simple approaches and one more complex. The first one is last write wins. I think we are very familiar with it. It's just simply the last who update the record is correct. So same example, scarf, hat, scarf reaches first, then device B tries to put the hat on and it wins because it was the last one. And hopefully at some point in time, device A is going to reconnect, fetch the latest data and get, oh, okay, this record, the actual value is dash with a hat. Then first write wins is very similar, but for the first one that reached the server. And yep, oh, there we go. And then as device B attempts to override it, the server just like answers back, hey, this was not correct. This is the correct version. So there are some considerations for simple conflict resolution. If you decide for one version or the other, in this case, let's say the first one, you're going to lose data. So there is going to be a chunk of data that is going to be lost because you picked one of the two. And then you pose the question, which version is the right version? The first one, the last one, and then usually, let's say it's usually the last, but what does first or last means? Especially because client-side timestamps are notoriously unreliable because they can be managed by the user. Or server timestamps are of course better, but if you're working in a distributed system, there has to be some logic behind to try to synchronize all the clocks from all the machines. So it's not a trivial solution. So the first solution could be, what if we merge? If you've seen the real-time updates in Firebase, this is probably something that you have seen when modifying Firestore documents. We get the same example, scarf, hat, scarf reaches first, hat reaches later. And then we just combine it and we have a dash with both elements. So, and then this gets pushed to the two devices. So this will usually look like this, name and here in this case, as properties are not overlapping or are the same, we just put it all together. And we say, okay, hero is yellow hat and outfit is going to be a yellow scarf. But what if we have some more complex scenarios like a gym dash, which has a lot of properties, many things in many accessories, and then on the other hand we have a rockstar dash. Then device A is going to say gym dash, rockstar dash, and then we have a more complex situation. In this case, usually the first time you discover it, you are going to find random things happening. For example, like something like a super dash that has nothing to do with any of the two options, you just get it in there. Or even, I mean, it looks nice in the presentation, but this usually, if you don't handle it correctly, is going to end up being your app crashing or data being forever lost. So you need to be careful with that. So same example with the JSON, and at the end, everything gets conflicting. And I added a Viking just because. Then we have some existing solution for sync conflicts. We already saw some of them, like simple conflict resolution, last right wins, first right wins. There are some very complex algorithms behind all resolution of conflict. So, for example, diff3 is using in version control like Git. There is operational transformation that is using things like Google Docs. And then we have CRDTs that are conflict-free, replicated data types. So this last one is the one that we've seen has had more adoption in the community up until now, more implementations in packages and libraries. So there are two main rules in CRDTs. So regardless of the order in which the operations are applied, the end result will always be the same. So it doesn't matter if there were many updates to the same thing. When you put it together in any of the devices, you should get to the same result. And applying the operation multiple times, so duplicated messages, should have no additional effect. So again, another example, we have 3 devices and we got 3 dashes, but device C is currently offline. So let's say on device A, I add a cup of coffee to the left wing from our perspective to dash. So we send a message to the server, add a coffee cup to the left wing. In this case, consider that there is going to be synchronization and everything, but we wanted to place it in a very simple way. Very important here to consider is that in the previous example, we were imagining sending the whole entity. So it was just like a completely overriding whatever was on the local database or on the server. When working with CRDTs, what you're actually doing is sending messages. So instead of saying, I want a new dash with a coffee cup, I'm saying, add a coffee cup to the left wing. So you start working with messages. So then, of course, as device B is connected, it gets the update because it's able to reconstruct everything. Same things happens. Device B adds a laptop on the right wing. It gets to device A. At some point in time, device C gets back online and fetches all the messages, and it's able to reconstruct the object based on the rules. And just for the sake, it adds a hat, and it gets to the other 2 devices. So something important with CRDTs, there are a lot of talks on YouTube online talking about the issue. At the end, it's not a trivial problem. You need to investigate a lot. There are papers written around CRDTs. There are like 8 or 9 famous algorithms that solve the CRDT problem. So that's why we are not like getting completely into it, because probably not everyone here is going to start working on a library implementing CRDT for Dart. There are already some packages and tools that do that we have found very useful in our development. So for that, I'll leave you with some info on packages and tools that we use with Gian.
Thanks. So yeah, for this, what we wanted to show you guys was mainly some of the packages and tooling behind this. So basically, once you get into like approaching an offline first approach, right? There are several strategies. On one hand, we work with backend as a services or maybe directly to databases. Typically, we have used like Firebase or MongoDB with the use of Realm. But if you would like to implement your whole customized backend and more traditional backend that scales. I think that the best approach would be to select a local database in your Flutter app, let's say. So yeah, here in theory you will have to select if you want to work with a relational or a non-relational. There are several packages such as, for example, in SQL or even ISAR, Hive, or Drift. Each of them like provides you like a more high level of abstraction or easyware to work. And in terms of the CRDTs, there are already packages out there, so you don't have to implement all by yourself. There is a really cool package that is more an abstraction that is called CRDT, and then the implementation in SQLite. So this was really useful because we started using it in one of our Flutter projects that we're also using like Dart in backend, and yeah, it was seamless the way we can manage these changes, and we didn't have to worry about the timestamps and other things. But yeah, you could always select like for your use case the particular strategy that you're going to apply. So these are like some packages to try it out. There are also examples in the packages, so you can play around. And then for the conclusions and next steps, I think like these are like some takeaways of today's talk. Offline first is not trivial. It's something that I introduce another complexity into our applications, because you mainly need to start worrying about like having a local database that maybe in your apps you don't have it. Data synchronization strategies that are like complex or requires like a lot of edge cases that we are not used to, because like our normal flow is simpler. Either it worked or it didn't. So yeah, remember you can enforce like working now and then sync back later. But at the end of the day, you will face like conflict resolution. Like this is a must for working with offline first. Maybe you have like a really easy app where you don't have to resolve any conflicts, but that will be if, for example, users are not sharing information. So at the end of the day, you will have to at least have a strategy, no matter how easy or hard it is, to solve this. And there are like different ways of handling success and errors. Remember, like having automated UI updates. And yeah, this is really important because ultimately we are having a better user experience overall, mainly because the performance is drastically improved. And I would highly recommend to consider this at the beginning of every project, because it also might affect how we approach in terms of architecture, or even how like the backend will be set up in terms of the endpoints, for example. So if we would want to have like offline capabilities in our app, and we decide to implement it later, it's going to be more difficult. I think like procrastinating that decision is not a good idea. Also one of the benefits that you can have that we didn't talk so much is that it can improve costs, because we are not going to constantly hit the server. Like the user is going to be syncing the information whenever we have connection, or depending on a series of criteria. So as a next steps, I feel like maybe we didn't say that, but we felt like there isn't so much information about this topic. I mean, every year there are some talks about this topic, and hopefully we continue growing this topic, because it's a really complex one in terms of finding what is the best approach to start working on. There are a lot of strategies and edge cases we need to cover. So what we did also was research, like how was the native community doing with this, either Android, iOS, because this is not a Flutter problem, it's like more a generic problem in every platform. And yeah, we found like a lot of good resources. For example, in Android developer guides, or even there was a droidcon called "Offline is not an error" a few years ago. So, and yeah, in the terms of Swift, for example, also there was a really cool talk about Swift connection in the Swift connection last year, offline first mobile app design. And also, here's the example that I was saying a few minutes ago, that it covers a full stack Dart with Flutter and Shelf, so it's really bare bones, with an example of how to use CRDT with a SQL database. So hopefully these next steps will encourage you to kind of try it out. I feel like once you implement it, like the magic goes away, and hopefully I personally feel like whenever you learn something, the next time you want to approach that, it would be like the most convenient way to handle it. So if you have this as a set of tools to implement in one of your apps, it will certainly benefit like the whole experience of what you are building. So yeah, that will be it. Thank you everyone for the opportunity. And yeah, those are our social networks. Yeah, thanks for having. If you have any questions, we can answer. I don't know, Eli, if you want to say something more.
Maybe just quickly, just as a key takeaway, the whole idea of the talk is that probably at the end, you're going to look for a package that is going to do the majority of the work for you. That is the reality of it. Of course, you need to understand how everything is working in the background and the logic behind the synchronization, the architecture, and everything. Because if you just say, okay, I'm going to start this project, and you had the opportunity, but you didn't take it, and you just went into the implementation, and then you decided to say, okay, I want offline first. If you don't first discover what are all the parts of the puzzle, then you're going to just get in a loophole and then say, oh, I should have thought about this and I didn't. So the whole idea of the talk is just like, these are the pieces of the puzzles that you are definitely going to encounter. Also, I just wanted to give a shout out to Dominic, which last year said that every year we should have an offline first talk. Last year it was him, this year is us, but hopefully next year it's going to be one of you talking about hopefully more concrete examples, share some code, but we cannot get there if we don't cover the basis first. So thank you.